Hello guys, so we have already discussed the top-down approach in the dynamic programming. So let's have a discussion on the bottom-up approach, which is also called as the tabulation technique. So as the name suggests, bottom-up, so we start to build the solution from the bottom and we accumulate our solution to up. So what I want to say is, let's take the same example which is called as the Fibonacci sequence. So we want to find out the fib of 6, like in the previous video we have found it. So what would be the smallest problem we would have? So we know that we have the base condition. One is that fib of 1 is 0 and fib of 2 is 1. So we know these two conditions. Then what we can do is we can simply create one array of fib 6 element. So we know that fib of 1 and 2. Fib of 1 is 0 and fib of 2 is 1. So we know these two. Then uh, instead of going from top to down and then hitting the base condition, then started to build up the solution from the bottom. So what we can do is we can simply start from the bottom itself. So what we can do is we know that B1 and we know fib of 1 and fib of 2. So what we can do is we can simply say that fib of 3 it would be fib of 3 will be uh, dp of 1 and dp of 2. That is we have the function of fib of n. So what we can do is in this question this is 6. So what we can do is we can create one array. For example, dp its length will be the 6. Okay. So what we can if we have an array, so this will be start from the 0 index. So in this case, our sixth number will be our fifth number. Our fifth index will point to the sixth number in the Fibonacci sequence. So what we will say is we know deep fib of 1 is equals to dp of 0, and we know that fib of 2 is dp of 1. So what we will do is we say that for I is equals to, we have to start from 2 and we have to reach till 5. What we will do is we say the dp of I would be dp of I minus 1 plus dp of I minus 2, and it will simply create our array. So we have started the loop from here. Indexing is 0 1 2 3 4 5. So what we will do, we say dp of 2 will be dp of 0 plus dp of 1, which will be 0 plus 1 will be 1. And then similarly dp of 3 will be 1 plus 1 2. Then dp of 4 will be 1 plus 2, that is 3. Then dp of 5 will be 3 plus 2, which is 5. And at last what we will say return dp of n minus 1, that is 5, the element at the fifth index. So in this way we can calculate our sixth Fibonacci number without using the recursive function. So this is called as the bottom up approach and is also called as the tabulation method. I hope that you understood the top down and the bottom up approach. And let's take one more example other than the Fibonacci sequence. And okay, so let's take an example of the factorial number. So we want to find out the factorial of 6. So what would be the factorial of the 6? Factorial of the 6 will be nothing but and this will be n. If this will be n, then we know that factorial of Fibonacci will be n into uh, factorial of n minus 1, factorial of n minus 1. This is also a uh, recursive function. So if we want to find out the factorial of 6, then how the function will be called? It would be nothing but 6 into f of 5. Similarly, f of 5 will be 5 into f of 4, then 4 into f of 3, then 3 into f of 2, and then 2 into f of 1. And we know that f of 1, our base condition will be f of 1 would be 1. Okay, so f of 2, it will return 1. So f of 2 will be 2 into 1, which will be 2. Similarly, 3 into 2 would be 6. It will return 6. So 4 into 6 will be 24. Then 24 would be written here. So 24 into 5 would be 120. Then 120 into 6 would be written to f of 6, and it would be 720. So it will become 720. So in this also, if we discuss the top-down approach, then in the top-down approach, we will have the recursive call from the f of 6, then it will call the f of 5, then f of 4, until we reach the base condition, that is f of 1, and we know that f of 1 is 1. Then we started building the solution from bottom to up. So it will f1 will return 1, and we will multiply with 2, then 2 will be returned to the f of 2. Then similarly we will go to up again, and we will get the f of 6 will be 720. If we want to discuss the bottom up approach, so we know that f of 1 is 1. Okay, then we can start the loop from 2 to 6, and we will have one uh, we can have array which will having the index from 0 to 5. So 0, and we have initialized dp of 0, that is factorial of 1 with 1. So we will say dp of I minus 1, because here I is 2 is we want factorial of 2, but factorial of 2 is stored in our array at index 1. So we say phi of I minus 1 is equals to I into dp of I minus 2. Okay, uh, we can have loop from, let's say we can have loop from 1 to 5, and we can say that dp of I will be I plus 1. You can do the both way. We can say I plus 1 into dp of I minus 1. So in this way we can calculate the factorial, and in this way we do not need to use the recursive function in the bottom up approach. So I hope that you understood the concept now, and we will discuss the problem using these approaches as we further go into the series of the DP that is dynamic programming.